Amateur radio is a DIY hobby. This not only makes it fun, but an adventure. Amateur radio operators are always coming up with innovative and inexpensive ways to build and utilize equipment. This is very true when it comes to antennas. Everyday household items can be used in the construction of a highly effective antenna. The better the antenna, the better the signal, and ultimately the better the contact. In this video, I am going to show you how to build a center-fed wire antenna. This antenna is incredibly easy to build, incredibly far-reaching, and very cheap. I mean under $5 cheap. Many new general class operators learn to build them to get in the high-frequency game quickly. The main point of showing you this is to demonstrate that amateur radio isn't rocket science, just more fun. The feed point can be used for different frequencies just by switching out the length of wires used. The length of the cut wire corresponds to desired operating frequencies used by amateur radio operators. To help you understand some basics, let me talk about feed point. Because there are many types of antennas used by amateur radio operators, and because this is intended to be an overview, I will describe this antenna in basic terms. The feed point of an antenna is where the coax cable leading from the radio connects with the antenna. Every antenna has one. The difference is where it is located. When talking about wire antennas, an end-fed antenna is exactly that. The feed point is on the end of the wire. A center-fed antenna is in the middle, and on an antenna that has an offset feed point means that the wire on one side is shorter than the other side. An interesting feature in working with wire antennas is that wires can be fixed in different positions to give the operator a greater chance of making the contact. These are the components necessary to build a simple center feed point for the antenna. The blue plate is from a cutting board. The blue plate is 3 inches by 5 inches. It was quickly cut out using a jigsaw. Amateur radio motto is, doesn't have to look pretty, it just has to work, especially if an operator finds themselves in an emergency or grid down situation. Improvisation is an important part of amateur radio. To the right of the plate is a SO239 panel mount connector. Also displayed are 4 little screws. These are used to mount the SO239 to the plate. The 2 longer screws will be used for the connection post, allowing the antenna wires to be connected to the feed point. The nuts and the wing nuts, along with 2 washers, are for the longer screws. These will complete the post. There are 3 circle electrical connectors, 2 for the black wire and 1 for the red wire. The 3rd washer is for the black wire when connected to the SO239 connector. There is a red and a black wire. The wires are at least 4.5 inches long. At a point in the process, the wire is going to be covered. Shrink tube or electrical tape. The hole at the top of the plate is centered horizontally. This is the hanger, a point where a cable or rope can be attached so the feed point can be elevated. Often used by operators in the field who sling the rope over a tall tree branch and hoist it up. Bottom 2 holes are roughly aligned. These will allow the antenna wire to be threaded through the back of the plate and attached to the posts. This gives stability to the wires and provides stress relief for the posts. Cut a 5/8 hole in the center of the plate. This is where the SO239 connector will mount to the plate. Next, set the connector in the center hole to use it as a guide and drill the 4 holes. Let's keep going. Drill 2 5/32 holes for the 2 posts. These should be about 3/4 of an inch from the center edge of the bottom circles. Now the focus will be on joining the SO239 connector with the red wire. I want to reduce the size of the wire without losing integrity so that it will more easily fit into the plug end of the SO239 connector. Take the red wire and remove about 1/2 inch off the end of that jacket. Fan out the wire until it looks like the bristle end of a paintbrush. Be gentle when rubbing it out. Do not damage the strands of wire. After fanning out the wire, cut along the side of the wire with a sharp wire cutter. From the outside edge of the wire, cut in an inward direction toward the end of the wire. Do this on both sides. Notice it resembles an arrowhead. The next step is to spin the wire around itself while gently pulling toward the end of the wire. This shapes the wire for inserting it into the plug for soldering. Now take the wire and the SO239 connector and mate them by taking the end of the wire and putting it into the hole at the end of the plug. When you mate them together, spin the wire in the same direction as when the wire was originally spun together. Use moderate pressure and push the wire in securely. Now it is ready for soldering. With a hot soldering iron, solder up and down the wire and the plug. The idea is to connect the two as securely as possible to increase the strength of the connection. Now take the shrink tubing and run it down the wire and onto the freshly soldered joint. Remember to let the connector cool first. When you apply the shrink tubing, place it so that only 1/4 of an inch covers the wire jacket. The area of the shrink tubing will be stiff. It is important to not have it hinder bending the wire to make the connection to the post. Use a hairdryer, heat gun, or a butane torch to heat the tubing. It will shrink nicely, giving the soldered connection more strength, along with stress relief. Plus, it hides the solder job, so you look like a pro. Now that we have the connector finished, everything will go quickly from here. Insert the connector in the center hole. Secure it with 3 screws. Do not put a screw in the hole on the upper left side. This is where the black wire will connect to the SO239. Time to build the posts for connecting the feed point to the antenna wires. Take one of the 2 long screws and thread it through the back of the plate. Do this for the 5/32 hole on the left side of the plate. In order, place a washer on the post and then add a nut. Do not tighten them down at this point. Repeat the same process for the post on the right side. For this step, on one end of the black wire, cut off approximately 1/2 inch of the jacket. Then install an electrical ring onto the end of the wire. Take the small screw, place a washer on it, then add the electrical ring and place it in the hole and screw it down lightly. Now, use a highly technical measuring device to determine the desired length of the black wire. Cut the wire at the chosen spot and add an electrical ring. Remove the nut from the post and add the electrical ring to the post. Add the nut and gently tighten it down. Position the black wire so that it does not block the holes for the hanger and antenna insertion point. Tighten down both the screw and the nut for the black wire. Perform the exact operation on the red wire. Only this time, take the wire and gently hold it with 2 fingers just above the shrink tube. Then use the other hand to gently curl the wire down and under to meet the connection post. This is the completed feed point. It is now ready for the addition of the antenna wires. By using electrical rings on the antenna wire, adding them to the feed point is easy. From the back of the plate, slip the end of the wire through the hole and add it to the post. Then take the wing nut and screw it down on the post hand tight. In the early stages of this video, I told you the feed point is where the cable from the radio connects to the antenna. In the end, we got there. We are not done yet. The discussion now needs to refocus and talk about wires. There are 2 types of wire that amateur radio operators work with: hard wire and soft wire. For this build, soft wire was chosen. I'm talking about the antenna wires exclusively. By using soft wire, the antenna package can easily be stuffed in a backpack for outdoor or emergency use. So soft wire is a better choice for short-term use. For a more permanent installation, this feed point should be paired with a hard wire. I also wanted to expand on the wire length itself. The 2 rolls of wire in the picture are 12-gauge wire and have an approximate length of 16.5 feet each. I'll talk about approximate length in a minute. The length of the wires correspond with the 20-meter frequency band. This is not a single frequency. This is a frequency band, meaning that on 20 meters, an extra-class licensed operator has several hundred frequencies to choose from. Let's talk about finishing the antenna. One end of the wires are attached to the feed point. What about the other end of the wires? We can't just let them flop around. So here is where I introduce insulators. Terminate the wire using an insulator. This picture is of 2 different insulators. The one on the left is a ceramic dog bone insulator. The one on the right is a DIY insulator made from a white cutting board. It was free. 2 insulators are needed for this build. The wire will loop through the top holes of the insulator. The wire is then wrapped around itself. Attached to the bottom portion of the insulator is antenna rope. When the feed point is up in the air, the wires are spread apart and the rope is staked to the ground. The antenna forms the shape of an upside-down V. Earlier, I mentioned the approximate length of the wires. Let's get back to that. The antenna is tuned using an antenna analyzer. I'm not going to elaborate on this now, but I will touch on it this way. The best way to get the exact length of wire we want for effective transmission is to hook it up to a meter. Always cut the wire longer than the antenna model requires. It is easier to shorten the wire than to try adding the wire back. There are many different antenna analyzers on the market. Only 2 will be highlighted here. I am not endorsing them, simply using them as examples. This is an old-school MFJ antenna analyzer, very popular and very accurate. It has only one function, very easy to learn and easy to use, does not fit in my shirt pocket. This is the new tech. The Nanovector Network Analyzer costs around a third of the MFJ and has many useful functions. I have both and find I use the Nano VNA most often. This is especially true when weight and portability is an issue when working outdoors. Easy to learn and easy to use. Fits neatly in my shirt pocket. I hope this video gives you some insight into the world of amateur radio. Thanks for taking the ride. If you are interested in getting an amateur radio license, contact your local ham radio club. For now, I'll just say 73.